Michael, what did you make of this?
Well, I'd have thought I scored as well. He's hit the target, he's run away. Kasper Schmeichel thought he scored as well. Then he's
look at the smile on his face.
Having a nice little chuckle.
It's a bit like me, Mal.
Nyoni, on a vu qu'il n'hésitait pas à frapper. Nyoni, bonne balle, pas de hors-jeu avec un roux dans ce but. Oh non! Oh, pas de chance! Pas de chance pour le Géant.
The video clips you just saw show a soccer ball stopping just before it passes the goal line. The force that stops the soccer ball from reaching the goal is called friction. Friction is a resisting force that slows down the velocity of the ball, eventually bringing it to rest. The purpose of this video is to see how friction affects a rolling soccer ball, and how friction differs based on the surface that the object is in contact with. The screen shows a free body diagram of a rolling soccer ball. As the ball rolls on the field, there are two vertical forces with equal magnitude but opposite directions on the ball. These are the normal and gravitational forces. A horizontal force, the force of friction, is also applied on the ball in the direction opposite to its motion. According to Sir Isaac Newton's second law of motion, the net force on an object is given by the mass of the object multiplied by its acceleration. The force of friction on the soccer ball is thus the mass of the ball times its acceleration. Since acceleration is the change in velocity divided by the change in time, we can find force of friction on the ball by finding the initial and final velocities, the time taken, and the mass of the ball. To compare the force of friction on the ball, a soccer ball was rolled on two different fields, a natural turf field used for soccer at the Diamond Middle School, and also a synthetic turf field found at Lincoln Fields near the Hayden Recreational Center. Videos of 3 trials were recorded using an iPhone camera, and then analyzed using the Logger Pro software by Vernier Software and Technology. The software was used to find initial and final velocities along with the time taken for the deceleration. The mass of the ball was 0.454 kilograms. By plugging in these measurements, we find that the average acceleration of the soccer ball on the synthetic turf field is given by negative 0.36 meters per second squared, which gives us a force of friction of 0.16 newtons. The average acceleration on a natural grass field is found to be negative 1.08 meters per second squared, giving a force friction 0.49 newtons. Finding the coefficient of friction for a rolling object is much more complicated than finding the coefficient of friction for a sliding object. For a rolling object, we must consider the radius, width, and deformation of the object as well as the deformation of the ground. However, we can still estimate the coefficient by assuming that the ball slides rather than rolls. If that is the case, the coefficient, also known as mu, is equal to the force of friction divided by the force normal. The radius of the soccer ball is approximately 0.1 meters. We find that the coefficient of friction of the synthetic turf field is equal to 0.036, while the coefficient of friction of the natural grass field is equal to 0.11. We can see that the coefficient of friction on the soccer ball on the natural grass field is 3 times as much as the coefficient of friction on the soccer ball on the synthetic turf field. To conclude, we found that the ball faces a higher deceleration on the natural grass field compared to the synthetic turf field. The synthetic turf field also applied a frictional force 3 times less than that of the natural grass field and thus had a lower coefficient of friction. Please note that in this video we made several assumptions that are not true in the real world, and this may have changed some of our results. First, we assumed that the ball slid on the ground rather than rolled across it. We also assumed that the only horizontal force was friction and disregarded air resistance and any wind that might have been blowing.